Hello learners, my name is Mr. Makambi Abusa from Anatolia Education Center. Welcome to today's lesson, whereby we are going to talk about the energy changes in physical and chemical processes. We know that energy is the ability to do work. And we also know that energy cannot be created. It can only be changed from one form to another. Like you can change heat energy to kinetic energy. Energy changes is commonly known as the enthalpy. When we talk of the enthalpy, whereby the enthalpy changes. Enthalpy simply means the amount of heat in a given substance. That is why under the energy changes, we are going to look at two processes: exothermic reactions, or the processes, exothermic reactions, and endothermic reactions. Now, what is the difference between the two? When we talk of exothermic reaction, in exothermic reaction, heat is absorbed from the surrounding. So, when we talk of the exothermic and endothermic, let's start with exothermic reactions. The exothermic reaction means what? That during this reaction, heat energy is given out to the surrounding. So here, heat energy is given out to the surrounding. In endothermic reaction, when you talk of endothermic reactions, in endothermic reactions, heat energy is absorbed from the surrounding. Now, we can use energy level diagrams to represent exothermic and endothermic processes. And here, I am going to start with endothermic reactions. Remember, in endothermic reactions, I've said that heat energy is absorbed from the surrounding. So, by drawing an energy level diagram, you will see that our energy level diagram will look like this, whereby this side you have energy. Remember, energy is given in kilojoule per mole. And down here, you are going to have the reaction progress. So we have the reaction progress, or the reaction path, means the same thing. So, since in endothermic reaction, energy is absorbed from the surrounding, remember, in a reaction, you have reactants, what is involved, and reactants will give you products. So, in endothermic reaction, the reactants will have less energy. So, here you have the reactants. They will have less energy than the products. In the products, you'll have them somewhere above here. So that is our energy level diagram, whereby now the reactants will have less energy. For example, if we can label our energy level diagram like this, then maybe this is 0, 5, 10, 15, 20, 25, 30. You'll find that the products will have an energy of about 30. So 30 kilojoule per mole. While in the reactants will have something like 10 kilojoule per mole. This difference between the reactants and the products gives us a positive value. So the endothermic reactions, they are always positive because the reactants will have less energy than the products. Now, in exothermic reactions, exothermic is different from endothermic, whereby in exothermic reactions, heat energy is given out to the surrounding. So exothermic reactions, we have said that exothermic reactions, they give heat energy to the surrounding. Again, I'm going to draw the energy level diagram to represent an exothermic process, whereby this side you have energy. This energy, it is given in kilojoule per mole. And on this side, we have the reaction progress or the reaction path. Because the reactants are going to have more energy than the products, our reactants will be somewhere above here. So we have the reactants. Then they lose heat energy. Then you are going to have the products down here. So in this case, again, for example, if this is 0, 5, 10, 15, 20, and maybe this is 30 kilojoule per mole, you'll find out that the reactants, you started with 30 kilojoule per mole, and you end up with, for example, 5 kilojoule per mole. So this one tells you what? That heat energy is being lost to the surrounding, giving an exothermic reaction a negative value. So all exothermic reactions have a negative value. Now, let's go to the real reactions, starting with our exothermic reactions. Dissolving sodium hydroxide in water is an example of an exothermic reaction whereby heat energy is going to be given out to the surrounding. So, if you have sodium hydroxide, which is a solid, and then you are reacting this one, or you are dissolving it in water, you will end up with sodium hydroxide, which is aqueous. And the enthalpy change here is going to be negative. So for example, you'll have negative 84.5 kilojoule per mole. So dissolving sodium hydroxide in water, it is an exothermic reaction. The same case with dissolving ammonium nitrate in water. So if you have ammonium nitrate here, ammonium nitrate, it is a solid. You are dissolving this one in water. You form ammonium nitrate aqueous. And this is an example of endothermic reaction. The enthalpy change, or the delta H, will be positive 25, maybe 0.5 kilojoule per mole. So those are two examples whereby we have an exothermic and endothermic reaction. Now, the next thing I want us to talk about is the bond breaking and bond formation during these endothermic reactions. When we dissolve the sodium hydroxide in water, we are breaking the bonds. So it is good for us to know how this one occurs. For a given reaction to take place, bonds must be broken, so that once we break bonds, new ones are formed. Now, bond breaking, and bond formation. For example, when hydrogen gas reacts with chlorine gas to form hydrogen chloride gas. This is an example of a reaction which occurs. And remember, before you do anything, we must balance our equation. And balancing means we have to simply put a 2 there. Now, let's see which bonds are being broken and which bonds are being formed. We are breaking the hydrogen bonds. So these are the bonds which we are breaking. We are also breaking the chlorine bonds. So these two bonds, the chlorine, and the hydrogen bonds are the ones we are breaking. For us to break the bonds, we need to supply some energy. So energy is needed to break the bonds. So bond breaking is an endothermic process because energy is needed. We are absorbing some energy to break the bonds. Therefore, we can say that bond breaking is simply an endothermic process. Once we break the bonds, we are forming new bonds. So, which bonds are we forming? We are forming these bonds, hydrogen-chlorine bond. So, these are the bonds which we are forming. To form new bonds, energy is given out. And because we know that an exothermic process, it is whereby energy is given out. So, this one, we say that energy is given out. So, we can conclude and then say that bond formation is an exothermic process. Because when you're forming new bonds, energy is given. Now, what is happening here? We want to see what is happening. Using a simple diagram, I'll explain the real situation the way it is. Again, I will use an energy level diagram like this. So, in the reactants, we have hydrogen plus chlorine. In this case, let me use a different compound like methane reacting with oxygen to give us carbon dioxide plus water. So this is gas, and liquid. So to balance this one, we simply put a 2 here. So you have 4 hydrogens, 4 oxygens, and then you put a 2 there. Now, in this case, the bonds which we are breaking 4 carbon hydrogen bonds. So 1, 2, 3, 4, the 4 carbon hydrogen bonds. Plus, we are breaking 2 oxygen bond so that we form new bonds And these new bonds are, you have carbon, oxygen, carbon, oxygen. So you are going to have this one plus 2 water or 2 hydrogen, oxygen bonds. So this is what is happening here, that when we form new bonds, we have to break the bonds. So basically, in the reactants, here we have bond breaking, and these are the bonds that we are breaking. So I'm bringing this reaction up here, plus 2 oxygen bonds. So when this happens, we will have separate atoms. Where separate atoms meaning what? That once now we break this bond, which is an endothermic process. So endothermic process leads to breaking of the bonds. We will have separate atoms, that is here now, separate atoms, which are carbon, 1 carbon, basically it's 1 carbon, plus 1, 2, 3, 4 hydrogens, plus 1, 2 oxygens. 2 times 2 is 4, so you have 4 oxygens. Those are the number of atoms that we are having. Remember, here energy is absorbed to break the bonds. So we are putting in energy so that we can break these bonds. Once we break the bonds, we have separate atoms. So these are the separate atoms that we are having. Then from there, we go down to the products now. We have the products, and the products that we are going to have is the carbon dioxide plus 2 hydrogen, oxygen, hydrogen. So you just put like this. And this is an exothermic process. Why? Because energy is given out when new bonds are formed. From there now, we can just do one calculation about the heat of a reaction. How do we know if a reaction is exothermic or endothermic given the bond energies? I'll use again this example here, whereby hydrogen reacts with chlorine to form 2 hydrogen chlorides. So the bond energy needed for this reaction, you are breaking hydrogen. So this is the bond, hydrogen, you'll have the chlorine bond, then you'll have the hydrogen chloride bond. So basically here we are saying that the bonds that you're having is this one, the first one, hydrogen bond, chlorine bond, and 2 hydrogen chloride bonds. So those are the bonds that we are breaking. The next thing that you're going to give you is the energy. So energy that is needed to break those bonds, and this energy, it is in kilojoule per mole. So the heat of this reaction can be calculated easily, because for you to break the hydrogen bond, you need positive 436 kilojoule per mole of energy. Chlorine is positive 244, and hydrogen chloride you need positive 432. So this information will be provided, it will be there, so the values will be given. Now, the next thing is to bring in now the amount of the heat energy that you need to break the bonds or bond breaking. Now, because bond breaking is an endothermic process, it is going to have a positive value. So let's see the bonds broken, that is in the reactant side. So we are breaking hydrogen bond, and for you to break this bond you need positive 436 kilojoule per mole. Another bond broken is the chlorine bond. For us to break the chlorine bond, we need positive 244 kilojoule per mole of energy. Now, what is the total energy? The total energy for breaking the bonds will be 6 plus 4, which is 10. And 1, this will be 8. And no. So you have total energy, 6 plus 4, which is 10. And 1, this is 4 plus 4, 8. Then 680 kilojoule per mole. This is the amount of energy that you need to break the bonds, positive 680 kilojoule per mole. Once we break the bonds, we are forming new bonds. So the bonds formed or bond formation, you're only forming hydrogen chlorine bond, but it is 2. So this one you're going to have 432 kilojoule per mole. This is the amount of energy which is going to be given out when you form new bonds. But remember, it is twice so, and it is an exothermic process, so the value will be negative 432 times 2, which gives you 4, 6, 8. So the total energy that is given out is negative 864 kilojoule per mole. So then the next thing is, how do we get the heat of the reaction? The heat of the reaction will be heat of the reaction equals to bond breaking plus bond formation. So which is, bond breaking is positive 680. So heat of the reaction will be equal to positive 680 kilojoule per mole plus negative 864. This is because bond formation is an exothermic process, and in exothermic process we have the negative sign. So our heat of the reaction will be, so you simply take 864 and you minus 680, gives you 481, and it is negative. So the heat of the reaction will be equal to negative 184 kilojoule per mole. Meaning what? That the whole process, when hydrogen reacts with chlorine, the heat that is going to be given is negative. Therefore, our process is exothermic because of the negative value. Now, from there, the next thing I want us to do is determining the enthalpy changes of a reaction. Enthalpy changes of a reaction. So, enthalpy changes. Remember, at the beginning of the lesson, I defined what is enthalpy, and we said that enthalpy is the amount of heat in a reaction, the amount of the heat given out, or the amount of heat which is going to be absorbed. Enthalpy is given symbol H. So once you see symbol H, this means the enthalpy or the heat content, the amount of heat energy in a given reaction, be it an exothermic process or endothermic process. So we cannot get the enthalpy of a reaction by directly measuring, but we can get the enthalpy of the reaction by getting the change in, for example, if there is temperature involved. So a change in the enthalpy is represented as delta H. So this is simply a change in the enthalpy. How do we get a change in the enthalpy? We get a change in the enthalpy by carrying out experiments in the lab, whereby enthalpy change will be equal to MC delta T. So you have MC delta T. This is the general formula for calculating the enthalpy change, whereby M is the mass. M is the mass in grams, the mass in grams of a solution. M is the mass in grams of a solution. C is the specific heat capacity. So C is the specific heat capacity. So our C is again a constant, and you are given the value. Then delta T is the change in temperature. Delta T is the change in temperature. So with all this information given, you can be able to know the amount of heat which is going to be given out during a given reaction.